Welcome to This Is My Architecture. I'm Matt from AWS, and today I'm joined by Danny Perschonok from Experian. Thanks for joining.
Thanks for having me, Matt.
So today we're going to talk about microservices and event-driven architectures. But before we do that, tell us a little bit about Experian. What do you do?
Sure. So I work for the consumer division of Experian, and the consumer division has all of the websites where somebody would come and just be able to sign up and grab their credit report.
Okay, so it's where customers go to sort of get their credit information, their data.
Exactly. See their new score, see their report, check all that data, yeah.
So I assume when customers are doing things like logging in or doing things, that's generating events, right?
It is generating events, exactly.
Great. So you guys made a move to the cloud, you moved to a microservices architecture, but before we go there, let's talk about what you were doing before.
Sure. So we were a monolithic system on-prem, primarily .NET, standard kind of three-tier architecture, web server, app server, database. But it was a very massive, clunky system. So
A monolithic architecture.
Exactly.
So you took the opportunity to move to the cloud, to move to a more modern DevOps model. When we talk about microservices, often there's a cultural or an organizational change involved as well. Did that happen at Experian?
Yes, we use this opportunity to break up our teams into, we call them domain teams, or as Amazon says, like a two-pizza team.
Okay.
So all the teams were going to focus on very specific areas. So we have a team that was focusing on customer profile or credit reports or credit alerts and CRM. So each of those have their own family of microservices that then they'll look after and deploy themselves.
Okay, so by breaking into smaller teams, you could be more efficient and develop more quickly.
Exactly. It allowed easier deployments, reduced dependencies, and just speed things up overall.
Okay, so how did this sort of decoupled organizational structure manifest itself in your agile microservice architecture?
So we realized that we had to make things asynchronous and really loosen up all the dependencies. So we really wanted to come up with an event-driven system. So one of the problems we had to solve was getting data into our CRM platform. So this is the customer microservice, for example. And as the customer is created, it's going to push off an event to SNS to say the customer was created.
So would one of the teams that you were talking about be responsible for like this module effectively?
Correct. This would be the customer profile team, for example, and
Got
then
it.
this over here would be our CRM team.
Okay.
So as the customer is created, it's going to create an event to say a customer was created. There's various services around the system that are going to be listening for that event. So we'll just call this service 3 and service 4. This event then gets pushed to this SQS queue, and it also gets pushed to this SQS queue. And these guys are sitting here polling, waiting to see what they want to do based on that event being created.
Great, so you've used a combination of sort of ECS clusters, SNS and SQS to not only decouple the teams, the CRM team and the customer team, but also actually to allow multiple queues to listen to sort of single event sources.
Exactly, yes. It's a one event to many queues.
So how does this service know where to push, and how does service 3 over here know what queue to read from?
So we have a centralized DynamoDB that we call service configuration, and as a microservice starts up, it reads all of its metadata from the DynamoDB table. So each microservice actually consists of 3 containers: an SQS listener that's pulling the SQS over there, an HTTP listener that takes all the incoming event, web requests before hitting the actual microservice, and then the microservice itself, which has all the business logic and what have you. So all of those will read the data on startup from DynamoDB. And for the SQS, it's going to say what queue it needs to read off of. It also has visibility timeout, so if messages need to live longer. And then it has the RESTful route to call. So basically, as it pulls the message from SQS, it looks and says, what route does this message map to? And then it does a RESTful call to the microservice behind it.
That's great. So I like how you're sort of decoupling your configuration data and putting it in DynamoDB. Does it just sit in Dynamo, or do you have any kind of a cache layer?
There is a Redis cache that sits in front of it to speed things up.
Got it. Yeah, because the whole goal of this architecture is to move quickly, right?
Exactly.
Okay, that's interesting. So what if a service team, like your customer team or the CRM team, wants to change their service? How does it work? Like, is that part decoupled as well from a deployment perspective?
It is. Everybody has their own, every microservice has its own GitHub repo locally and Jenkins jobs to deploy independently. Nice. So everybody can do deployments whenever they need to. It's not going to impact the other teams. So the customer profile needs to do a deployment, it will do it on its own, and it's not going to impact the CRM team, because the CRM team services are just sitting over here running, still listening to its events and doing their thing.
That's great. So you mentioned before when you were talking about your previous environment on premises that it was .NET. Are you still running .NET in these services here?
We are actually, yes. So the The two listeners that sit in front of the microservice itself are Node.js, but the primary business logic is .NET Core.
Oh.
So that's .NET running natively on Linux, and all of these are Linux servers.
Wow, so you're running .NET Core on Linux in
Yes.
addition to Node.js, so you're a polyglot
We
developer
are,
organization.
and we actually have some Java services as well. We're about 75% .NET, 25% Java, with all the microservices having the two Node.js services sitting in front of them.
Wow, so that's amazing. So you've actually not only decoupled the teams and decoupled the different tiers of your architecture, but even it's given you the ability to deploy in multiple languages and different tasks within an ECS cluster.
Absolutely, absolutely. Yeah, it's been a lot of fun to be able to see other people learn different languages and how those are going to work in the cloud.
Very cool. Well, I really like how you're using ECS, the ECS clusters, the multiple tasks to sort of enable multiple languages. .NET Core on Linux is something great to see. The use of SQS and SNS to allow you to really do things in parallel is interesting. Decoupling your configuration data down in a DynamoDB database, it's a really interesting architecture, and it's great to see your organizational sort of agile structure mapped and mirrored in the architecture you have here. It's really nice.
Yeah, it's been a fun journey.
Yeah, so thanks for sharing your architecture with us
Well,
today.
thanks for having me.
And thanks for watching. This is My Architecture.